Once we can store values in variables, we might want to perform some calculations with those values. Arithmetic is completed using operators, which are basically symbols that get executed as commands or operations when your program runs. C# has 5 different arithmetic operations: addition, subtraction, multiplication, division, and one called modulus. Let's look at addition and learn a few nerdy words. The operator we'll use is, predictably, the plus symbol. The values an operator needs are called operands, and the arithmetic operators we'll look at all take 2 operands. By that I mean, to do addition, we have to provide 2 numbers. Because it requires 2 numbers, or operands, we call it a binary operator. While we won't look at them in this video, there are operators that take only 1 operand, and those are called unary operators. And an operator that takes 3 operands is a ternary operator. And you thought you weren't going to learn anything interesting today. So the addition operation consists of a number, the plus symbol, and another number. An operation by itself isn't a complete statement in C#. It's what we might call an expression, and that expression evaluates to a result. This one evaluates to the value of 5, of course, but this code isn't doing anything with that result. In fact, it doesn't even compile. We really need to put this expression or operation into some kind of a statement. I could put it in a write-line statement and the code would work like we expect. It would print out the number 5. Even though this code works fine, I don't really like putting arithmetic inside of a write-line statement. My preference is to keep operations separate from output. So what I'll do is use an assignment statement to put the result into a variable. Then I'll print out the variable. That might seem pointless right now. Why bother with the extra steps? I do have my reasons, and we'll get to those down the road a little. For now, the point is that we're learning about variables and assignment statements. So code that doesn't use variables and assignment statements won't really get any credit on work that you turn in. Hopefully that's reason enough for you to do it this way, at least for now. Remember that an assignment statement centers on that equal symbol. At runtime, it's going to evaluate the expression on the right of the symbol and put the result into the variable on the left. In this example, both of my operands are just numbers I've typed into my source code. We call these numeric literals, or we might use the phrase hard-coded, as in the values are hard-coded in my program. These are constant values that can't change once the program starts running. I can only change them by deleting them and then retyping something else before I run it. But operands can also be variables. When the program gets to this assignment statement, it starts on the right and retrieves the values stored in those variables, evaluates the addition operation, and assigns the result to the total variable. The subtraction operator works the same way, but using the minus symbol. Multiplication isn't going to be anything new, but we'll at least use a floating point value this time. The operator is just going to be the star symbol, which we really call asterisk. If either of the operands is a double, the result of the operation will also be a double. Next up is division, which uses the slash symbol. And pay attention because there's a slash and a backslash. This is the one down at the bottom of your keyboard on the same key as your question mark. Now, if both operands are integers, C# will do integer division, which can't have any decimal data. So the result can't be 6.67. The tricky thing here is that C# doesn't round this up to 7, which is what a lot of us might expect. C# just chops off the decimal data and makes the answer 6. That chopping behavior is called truncating. You're learning all kinds of great words today. There are situations where integer division or truncated division is useful, but most of the time we probably want that exact number. So we'll want to put the result into a double. I'm storing the result in a double variable here, but it's the operands that determine if the answer gets truncated. Remember, if both operands are integers, the result is an integer. So we'll need to make one of those a double. It actually doesn't matter which one we change, just as long as one is a double. In general, we should try and use the most appropriate data type for the values we're storing. In this example, I have the ages of 3 people, which are all integers, as well as the number of people in the group, again, an integer. But I want to calculate the average age in the group. How can I do that without making one of those into a double? We can use something called typecasting, or just casting. Casting is when we convert a variable from one data type to another. I could just make a double variable and then assign the integer value to it. C# will make that conversion automatically by adding the 0.0 to it. This is called implicit casting because we didn't actually tell C# to do that. But I can also do explicit casting and do it in a manner that doesn't permanently change any values or variables. I just put the desired data type in parentheses immediately before the variable or literal value. When the program executes, C# will convert this 3 into a 3.0 on the fly when it does the division, which gives us the floating point division we're looking for. One last word about division. Don't divide by 0. I'm not a mathematician, but I guess dividing by 0 causes the universe to explode or something. In our code, it causes our program to crash. Sometimes we can't prevent that from happening. Maybe we make some other calculation and then use that result in a division operation, and when the program runs, that value turns out to be a 0. Later in our programming life, we'll learn a graceful way to handle that kind of error, which we call an exception. But for now, it just makes our program crash, and there's not much we can do about it. Speaking of mathematicians, there's another thing from your old math classes that comes into play here. Order of operations. I'll leave the details for you to read about, but know that you can use parentheses to force the order of operations you need, just like in your math class. Now, I know what you're thinking. I've already learned so many interesting things in this video, there can't possibly be anything else. But you're wrong. I mentioned one more operation called the modulus operation. It uses the modulo operator, which is the percent symbol. Modulus finds the remainder after an integer division operation. This goes back to when you learned long division as a kid. When you divide 10 by 6, you get 1 with a remainder of 4. So 10 modulo 6 returns that remainder of 4. When you divide 25 by 4, you get 6 with a remainder of 1. So the division operation returns 6, and the modulus operation returns 1. This seems like a weird operation to care about, but it does have some interesting applications in coding. We can use it to find our way around a two-dimensional array once we know what that is, or we can handle screen wrapping in a video game. Stuff that we probably aren't worried about right now, but file modulus away for future reference, or use it this weekend to impress someone at a party. And with that, I pretty much am out of interesting things to say about math operations in C#. Just like in your math class, these 4 or 5 basic operations make a bunch of more advanced stuff possible. So be sure to take a few minutes to try them all out on your own.